Okay, let's dive into this. We spend a ton of time talking about building and launching AI systems, right? But what happens after they go live? That's what we're going to break down today. The really critical disciplines of managing AI out in the real world. So let's just start with this foundational question. Imagine this. You've done all the hard work, you've pushed the button, and the system is deployed. Is the job done? Is that system now, a finished product, just locked in and complete? The answer to that is a hard no. And thinking otherwise isn't just a little mistake. It is a genuinely dangerous assumption, one that can lead to some really big problems down the line. Let's dig into why. Okay, so this brings us to our first big idea, the static system myth. It's this belief that an AI system, once it's live, is kind of a set-it-and-forget-it piece of tech. And honestly, we need to completely dismantle that way of thinking. And the idea here is, it's simple, but it's really powerful. This is the fundamental truth we've got to wrap our heads around. You see, unlike traditional software that only changes when you, say, push out a patch, AI systems are dynamic. They're basically living systems. They evolve. All right, so if these systems are constantly changing, what do we actually call that? Well, this brings us to a super important term for anyone operating AI: system drift. Let's get into what that actually means. So, drift, what is it? It's that gradual shift in a system's behavior over time. And look, the most critical part of this whole definition is that last phrase, even when users do not change prompts. This isn't about people trying new things. This is about the system itself changing, right from underneath them. So what's causing this? I mean, it's not magic, right? Drift is introduced by real, concrete operational changes. We're talking about things like updating the underlying model you're using, maybe adjusting how queries get routed through the system, changing a default setting like the temperature, or even just updating the data the system can pull from to form an answer. Any one of these can subtly, or sometimes, dramatically, alter the system's behavior. Yeah, let's just pause on this point for a second because it is the central idea here. Think about it. Your most reliable, consistent user could run the exact same prompt they ran yesterday and get a totally different result today. Not because they changed anything, but because the system did. And this is where we really need a shift in our mindset. We can't treat drifts like it's a bug or some sign of failure. It's an inherent property of these systems. It's just a natural consequence of operating these incredibly complex things. So the goal isn't to eliminate drift, because you can't. It's to manage it. Okay, so if we accept that systems are going to drift, how do we manage their growth? How do we expand their use? This leads us to our first core discipline, what's called deliberate system promotion. And this is all about moving a system from a controlled environment to a broader one in a really structured, intentional way. And here's why this is so important. A system might work perfectly for a small team of experts who are all working on a very narrow set of tasks. But what happens when you promote it to the entire company? Well, now you've got new users, new data, new kinds of tasks, and all of that creates a brand new context. And the system's previously acceptable behavior? Yeah, that's no longer guaranteed. Because of that, the decision to promote a system can't just be casual. It has to be a formal evaluation. You really have to ask yourself some hard questions. How stable is the system right now? What's the range, the variance of its behavior? And this one's crucial. What are its known failure modes? And are we actually prepared for them in this new, wider context? Okay, so if promotion is about moving forward carefully, what happens when things go wrong? And they will. This is where our second core discipline comes in. We have to start thinking of rollback as a planned, essential capability, not a panic button. So the key point here is this. Rollback isn't some frantic emergency undo button you hit when you're in trouble. It is a capability that you design into the system from the very beginning. It's your safety net. It allows you to instantly revert the system back to a version that you know is stable and well-behaved, especially if the current one starts drifting into an unacceptable state. And this might be the most important takeaway about this whole concept. Using a rollback isn't you admitting that you failed. It's a sign of operational maturity. It proves you have a safety-first mindset and that you've built the mechanisms you need to actually govern your system effectively. All right, so we've talked about drift, we've talked about promotion, and we've talked about rollback. Let's pull it all together now. This is really about moving from thinking of AI as a one-time project to treating it as a system that has an ongoing life cycle, one that requires constant management. In this life cycle, it really looks like a continuous loop. First, you deploy a system in a known, stable state. Then, you actively monitor it for any behavioral drift. When it's proven to be stable, You formally evaluate it for promotion into a wider context. And all the while, you are maintaining that capability to roll back to a previous known state at a moment's notice. And then, the whole cycle just repeats. And this is exactly why we need these formal processes. Simple analogies and mental models, they're great when you're first learning this stuff, but they just aren't enough to run things safely at an organizational level. For that, you need formal, disciplined models, like the life cycle we just talked about, to manage risk and ensure there's accountability. So ultimately, it really comes down to two paths you can take. On one path, without this kind of disciplined life cycle, changes just pile up silently. And before you know it, the system's behavior is completely unpredictable and uncontrolled. But on the other path, with it, the system's behavior remains controlled, it remains understood, and most importantly, it remains explainable. So I'm going to leave you with this question to think about. When you look at the AI that you use, or maybe the one you're building, which is it? Is it being treated like some static, unmanaged product that's just left to drift on its own? Or is it being treated as a dynamic, governed system managed with real discipline? Because honestly, the difference between those two, that's the difference between risk and reliability.